So welcome everyone. Welcome to this Pydata Berlin February edition 2021. One more time online. So we have two talks today. But first, I would like to remind you about Pydata. So we are part of NumFOCUS, and as part of NumFOCUS, we have a code of conduct. The short version being be nice, do not be respectful of the others, and everything will be fine. And without further notice, let's go to the first talk by Vincent. So we will talk about his work as Rosa and about chatbots. Please, if you have any questions, do not hesitate to write it in the chat, or if you're on the YouTube, you can also put it in the chat there, and we'll forward it to the speaker.
Cool. Let me just make sure I've got my chat window open here as well, so that looks good. Also to the crowd, like we can see me doodle, I hope, right? This is something we can all see.
Yes.
Grand. So, hi everyone, my name is Vincent. I won't be talking about chatbots too much today. I'll talk about all sorts of byproducts that we've got now, but I won't be talking too much about chatbots themselves. First of all, hello, my name is Vincent. I'm a research advocate at Rasa. So a big part of what I do is I make some YouTube videos to explain like some of the algorithms that we make. And the reason that I do this is because it's my job to sort of interface on one end with our research team, and we're doing kind of advanced numerical tricks to make chatbots work. So there's like complicated stuff here. And I need to interface with developers as well. And the main thing that I'm trying to do is make sure that some of the things that our research team does is, accessible to my lovely group of community developers here, but also the other way around, that if cool things are happening in, the community, that the research team is also kind of aware of that. And this is the ground that I'm trying to cover. I do a little bit of research, but I'm also a little bit more focused toward developer advocacy, so to say. In particular, you can kind of pick the problem you work on at Rasa. But in particular, I'm very interested in doing everything possible to me for non-English use cases. I think there's a lot of cool papers and a lot of really cool work on English natural language processing, but the world is much bigger, right? It's not just English. We need multiple languages supported. And my particular realm of interest is this non-English bit. So some of the things I do at Rasa is I open source a couple of tools that are useful to explore this. I also host some Rasa compatible tools for non-English developers. But the interesting thing that happened last year, which I didn't really anticipate, is that, besides me being Vincent, the guy who works at Rasa and the person who's a research advocate, I'm also like an open source kind of person. I have lots of hobby projects and lots of projects that I maintain, and also lots of projects that I contribute to. Fair Learn is a project I've spent some effort on. There's some of these loose scikit-learn compatible packages that I maintain. And I like to think of myself as someone who's actively working for Rasa. But while I work for Rasa, I also have my own independent work that I'm doing on the side. Keep your eyes peeled for a tool that's going to come out next week, by the way. But if I'm going to talk about anything today, what I would really like to talk about is how this kind of weird, happy open source accident happened. Because what happened a couple of months ago is I was working on my own thing while working on the Rasa thing. And it turned out that these two completely different tracks of work were able to merge in a very lovely way. And the reason why I think I want to maybe focus in on that is because it also gives us an observation on maybe this new mindset that we might be able to do in research, which to me at least was kind of a neat observation. Having said all of this, what I'm going to do now for the rest of the talk is live demoing. So I'm going to try to explain what I mean by everything I've just said. So, shortcuts. There we go. I'm hoping can people read this? This is like good size, font-wise? Okay, cool. I think it was about 5 months ago. I started this open source project called Human Learn. And it's kind of like scikit-learn, but the idea is instead of algorithms trying to find patterns, it'd be kind of nice if we had a way to have humans come up with decent rules instead. I think there's a lot of really good domain knowledge, and I would like to have domain knowledge be more scikit-learn compatible. Kind of, a little bit of a project that goes against the hype. But the main idea I really want to do is I want to make it easier for people to write rules that can take in data and produce labels. Because I think there's a lot of human intelligence, natural intelligence that we can do here instead of just always focusing on the artificial kind. And there's a bunch of features in this library that is really, really lovely. But here's my favorite one. Let's say that this is a data set that you're interested in classifying. Right? So you've got your red dots, you've got your green dots, you've got your blue dots. We've got an enterprise use case. We want to do the classification thing. That's the thing we're interested in. Then what you could do is you could say, well, let's do this complicated algorithm thing. And that's this geometric trick that's going to separate all of these classes. But I hope that you recognize just from looking at this particular data set, you don't need any like TensorFlow or anything like that here. You just kind of want to draw a circle around the class and just say, if a new point falls within this shape, then I'll just call that red. So one of the main features that this library allows you to do is it allows you to do exactly this. You can just draw a shape. Oh, I need to use the actual mouse for this. My bad. It's not great for everything. But what this library basically allows you to do is you can just sort of draw a shape and say, okay, that's the red class. Here's the blue one. Here's the green one. And if we ever get like a new data point in, then we can kind of do this point and poly algorithm thing where, if a point falls here, it's probably green. And if there's a point over here, well, then it's probably an outlier. Like we can do very simple stuff like this, really, if you think about it. The data's already there. And I could do this on multiple axes, right? So I can do this with 2 dimensions, but I can do this with n dimensions, but just making more of these separate charts, and you can keep drawing. But what I thought was pretty neat is just sort of the whole design aspect of this. What I just did is all the data that I just drew is inside of this variable over here. And I'm putting that inside of this interactive classifier, which is basically saying, take what I drew over here and turn it into something that scikit-learn can handle that you can also grid search over if you really wanted to. And just as a proof of concept, you can see that, what I just drew are also the predictions that we're making here. But the main thing that I liked about this view is just the whole point of when you're exploring a data set the first time, you don't want to do the XGBoost thing. You actually want to sort of actually go and explore a data set. And by doing this trick first, if only as a benchmark, you have this nice little aspect that you're forced to actually look at your data and think about it. And that was kind of the point I wanted to make with this library. Just a sort of idea of, you don't always need complex algorithms. You can also maybe get some domain knowledge in and have like a benchmark model based on that. So if that works pretty well, then maybe you don't need TensorFlow. That was sort of the vantage point that I had. Now, what I'm showing you here, this is something I made on my own. It's just something I figured would be a cool thing to do. And the nice thing about living on GitHub sometimes is that people can collaborate, and there's some really interesting projects out there. I'm not doing anything super serious with this, but I have heard people like use this in production, which is pretty neat. But this was something I was doing on my own end. While I was doing this, though, I also started working at Rasa. And at Rasa, we noticed that we kind of had this one sort of interesting issue, and that was that on one end, we wanted to make sure that people who were using Rasa kind of understood word embeddings and also what's in them. And on the other side, we also figured, well, it'd be kind of nice if we had this really like just useful, quick API that allows us to just evaluate a bunch of embeddings real quick. We kind of need this library that tells us what lies in word embeddings. And that's how the ball got rolling on this project that's hosted on Rasa. It's independent of Rasa. You can just download it independently. But the idea of this package is called what lies because we want to use it to figure out what lies in word embeddings. The way it works is you can say, well, there's a backend. In this case, I'm saying, well, let's take some byte pair embeddings. Those are a particular kind of word embedding that's robust against spelling mistakes. And then I have this language object. And what I can do is I can kind of like Pandas style, just say, look, if this is a dictionary of sorts with all sorts of word embeddings, I just want to put all of my words in there and then get sort of a data frame out that represents like a collection of vectors, like names with arrays, so to say. So one thing that just for demonstration purposes, if I take that bypair language and I give it the word man, then I get this embedding object, and inside of that is this this vector, so to say. So this is just a retrieval method to get like vectors out. But the cool thing about having that in like a data frame kind of setting instead is that you can more easily add plotting functionality on top of that. So one thing that I can do is I can say, could you just plot the similarity between all the words that are in here? Let's use cosine distance for that. Metric. And what's kind of nice and funny and interesting and cool is that you can sort of see, well, there's a couple of word clusters happening inside of here. And this gives us like a very convenient way to maybe explore that, because I can also tweak the settings here a bit. I can say, well, I would like to have like a larger vocabulary size or a smaller one. There's all sorts of settings that I can tweak here. But I have this nifty little plotting functionality that's available to me. Now, what's nice about this is that byte pair embeddings are just one kind of embedding, but there's also other types of embeddings. You can make embeddings based off of scikit-learn. You can make a TF-IDF vector embedding. You can get embeddings from Hugging Face. You can get them from TensorFlow. But what Lyse tries to do is, what Lyse basically says, well, we make sure that you just have to talk to like one single API and one single API only. And we do our best to make sure that we cover as much ground as far as support goes. So that means that we actually have a couple of backends that we support out of the box. So Jensen, we do some of the scikit-learn tricks we do, fast text, SentenceBERT, Hugging Face, Spacey, TensorFlow Hub, like these are all natively supported. So if you have any embedding from those, then you can just use our library to do visual stuff, basically. But it's not just visual stuff that we do, because all of our language embeddings are also scikit-learn compatible. So I'm assuming I'm talking to a crowd who's done scikit-learn before. So if you have like your data set in this XY format and you would like to make a prediction, then you can use any language model that this library provides, and it will behave like a transformer, like a standard scalar, so to say. All of these language models that you have here are models where text goes in on one side of the component. Let's just draw that out. And on the other side, you get basically a vector that belongs to that text. And it doesn't matter if you're using Hugging Face, you can always use this API. So if you just want to do some quick benchmarks on whatever language you're interested in, you can totally do that here. And there's one thing that's actually particularly cool about this byte pair language setting, because the byte pair embeddings itself, we can kind of just maybe just show you the website real quick, BPM. It's a project that there's a couple of numeric tricks that are happening inside of this library too that are really awesome. But the main thing that's really epic about this project in particular is that it supports 275 languages. So even if you're working in non-English, odds are that there is a pre-trained language embedding for you that you can go ahead and play with. So just to give a quick demo, what I'm just going to go ahead and do is just type in the word embedding languages that people were asking for in the chat. So I think Romanian was one of them, but Romanian is definitely supported. So what I can do is I can sort of take this language code over here and just put that inside of scikit-learn and sort of play around with it. This is the only change you need to do to have a language embedding for Romanian. And when you run this, the first time it will sort of download all of these things, but once it's done downloading, you're good to go. So just as a demo, right, because I think it'd be kind of cool to show, what I've got here is Greek. So just some Greek words, and I took the words that I had before to Google Translate. And you can see that, you know, we get the same similarity chart out, which is definitely kind of nice. And this is nice because you can also then make the comparison of, hey, are the same kind of word embedding trained on English Wikipedia do the embeddings represent something differently than if I do that for Turkish or whatever other language? But I also support languages like Telugu indirectly. However, if you use those languages, you get into this interesting other dimension of support for language. Because I support, like, the vectors just come out, that's completely fine. But the issue with some languages in matplotlib is that matplotlib cannot always handle the characters, which is also this sort of small little bummer. So luckily, one thing that we can do nowadays on the web is we could say, well, instead of relying on matplotlib, it would be nice if we can have like a rendering engine that's kind of guaranteed to be able to handle most language typesets. So what we also offer are visualizations that are based on the, oh, whoops, I need to rerun that, sorry. I thought I ran this. There we go. But what we can do is we can say, well, I'm interested in making this plot, but I want to plot it directly on a web interface. So that's what you see here. Because, you know, a browser is actually meant to be able to render just about anything, you'll find that there's a lot better language support if you just have an interactive visualization that can just, you know, draw on the canvas, so to say. So one of the things that we also support is we also support this idea of, you know, take the word embeddings. This is a data frame with embeddings, so to say. And we can say, well, let's transform that by doing a principal components analysis. And let's then make these altair charts. So you can have, like, you know, these interactive visualizations on the PCA dimensions. Zoom out once more so you can kind of see it. And what's kind of cool here is, you know, you can kind of explore where some of the clusters are. And if you're working in the multi-language setting, you would really like to confirm that certain clusters that you expect are actually in here before you put it into a classifier. So, you know, this, I figured this is pretty useful. This is pretty interesting, right? Like, we have scikit-learn compatibility, we have Hugging Face and all these language backends. That's pretty cool. But here's where the happy accident happened. I have these views, right? So I can definitely see, like, hey, there's a cluster over here. But at the same time, I was also looking at this chart and sort of going, you know what, what's really nice about this is that I can just draw a circle around like a couple of points and sort of assign a label to that using this trick that I've got here inside of human learn. That idea is pretty nice. And if I now start looking at what I've got here and, you know, what is actually going to be useful to, like, some of my Rasa end users who I'm trying to help with non-English, well, then I might need to take a step back and wonder, maybe we shouldn't use these embeddings just for classification. Maybe that's not necessarily the big problem. You see, a lot of these embeddings, in the end, they're trained on something like Wikipedia. And if you think about what Wikipedia represents, that's, you know, amazing spelling, super formal, probably about something in history. But if you think about how language is used online and, like, in a more, you know, assistant setting, it'll be like full of spelling errors, super informal, and something that's happening right now as opposed to something that happened a long time ago. So maybe, you know, these embeddings are, like, pretty interesting and all, but maybe it's not just for making classifications that they're interesting. Maybe instead we should use them for labeling. Because you notice that there is this clustering happening here, right? And you can imagine that if you're starting out with a new assistant in a non-English setting, that probably the first problem that you have isn't, do I have embeddings, but it's, do I have appropriate training data in the first place? If you're working on an assistant and let's say you're a business, then the likely scenario is that you do have, let's say, some social media data of, like, customers asking frequently asked questions, or, like, you know, you have these logs of conversations that you already had. And it might be a better idea to wonder, like, can we take that data and maybe more quickly label that real quick to get, like, a gold label standard going as quickly as possible, as opposed to, like, only taking a few data sets with, like, a few labels and using word embeddings to optimize there. So that got me thinking, like, hey, maybe I need to combine the human learn idea with this what lies thing that I've got going. So that's what I've done here. Now, I'm about to show you a demo, but just to give you an impression of what's happening, right? The way that this is a notebook, and it's kind of a project on its own that's open source, everyone can download it. But the way that this works is I assume that you have text that we would like to label. I then pass that through a language model, and that can be anything. It can be something based on TensorFlow, Hugging Face, or whatever. I then end up with a embedding of sorts. And then what I can then do is a dimensionality reduction technique that lures the clusters out to then give me a two-dimensional view. And then probably what I can do is in this two-dimensional view, I can do the trick where I do the selection. And maybe this is a very convenient way for me to do like bulk labeling. I won't be getting gold labels, but I will be getting like maybe bronze or silver ones. And the idea here isn't so much that I get like the best labels right away, but it is the idea that I am able to plow through lots of data relatively quickly. So what I've got here is a training file from a Rasa bot. I've passed that through the universal sentence encoder. That went through UMAP, and what you end up with is plotted here. And what I'm able to do is just make a selection of a particular cluster. And I can say, well, let's show the examples of that cluster. And one of the like really convenient things these days at the Jupyter Lab is that these widgets just kind of work. So you can just make your own user interface happen real quick here. And you know, there's actually like a whole bunch of points here. I can actually probably just maybe zoom in just a little bit here. But there's like a lot of points over on this end. So instead of like assuming that these are all the rows, I can hit this show examples like a couple of times to get an impression of what's happening there. But at the moment, I do think like, hey, this is all about like restaurants and food. So let's just say this is about like food. I think that's a good label for like all the points that I have there. So that's 55 data points. That's nice. Let's maybe pick up that view and move that down here and see what is over there. Okay, that's all about age. All right, fair enough. So let's add all of those labels. Maybe do over here. Let's have a look there. Show examples. Okay, that's all about jokes. Joke, add label. Now, I did a couple of clusters just now, and I don't really need to see them anymore. So what I can also just do now is just hit redraw. Basically, it just draws all the points that aren't labeled yet. So I can repeat this exercise now. Let's just zoom in on this. Yeah, let's do a cluster over here. All right, let's just show the examples again. Okay, this is what's the time. All right, that's also a good cluster over there. Let's maybe do this one. Show examples. Okay, that's nice to meet. Okay, so I got a couple of labels now. That's pretty good. But now that I think of it, if I sort of redraw now, I do have a couple of these clusters that are just a little bit more clumped together. They're a little bit closer, and I might want to sort of pull them apart again. So what you can do is you can say, well, let's not retrain this whole language embedding. But what we could do is say, well, let's keep using the same embeddings we had here, but let's just retrain UMAP. And that way we might also still be able to pull apart some of these clusters to make it more easily to sort of bulk label. And that's what this retrain button does. It takes a little while, but after a bit, all the UI elements are back. And we see that like the chart has reoriented a little bit, the clusters have moved, etc. And you know, I could basically repeat the same exercise. Oh. Draw that shape over here, show examples. Yeah, about the weather. What you do see is if you move over a cluster here, I mean, it's not necessarily a guarantee that things will cluster apart this nicely in real life. I'm using a training data set here, which is giving it a bit of a biased perspective. But in reality, one thing that you can imagine is that you might need to actually zoom in a bit here. So here, like, what's the time? Who is your boss? What company created you? You can imagine there's a couple of classes actually sort of hidden in here. So it's not like you can have like a free lunch. Like you still probably have to sort of go in here and do like deep investigation. But as a way to get started, if I think about it, maybe this is a really good idea. What we're looking for are ways for people to get to their gold standard data set as quickly as possible. And given that I have on one end a pretty cool user interface that can deal with this part, and on the other end, I have this library full of embeddings that are just ready to go, pre-trained in whatever backend you like, I think we can cover kind of a lot of ground here. So this idea of maybe doing more bulk labeling as a method of getting people, their bootstrap together, I mean, there is merit to that idea, I think. So this is my active research area at the moment. And the thing with this is, just to show, you can nicely export this. You get all of your labels in a nice data frame. So the thing is, I can try this out on a bunch of data sets, and that's pretty cool. That's pretty nice. But what I cannot do is run this in every language out there and confirm that this is actually working. For that, I kind of need this community around me to tell me like, hey, Vincent, that trick works well for this language and this trick works well for another language. So what my job at Rasa currently kind of is I support the research team in explaining what our algorithms are. But a big other part of my job is to make sort of these byproducts like this and to see if this is useful to like the larger community out there. In order to verify that, though, I need to speak at meetups and like kindly ask everyone here if this trick works. So if you want to give this a go, like I'll share the links and everything. All of this stuff is open source, so you can just goof around whatever you feel like. But I would love to learn if this is something that helps you get started with a training data set in the first place. Because that's something I would love to get feedback on. And that is something that I cannot benchmark on my own. I actually need community feedback for this. So that's the main thing I actually just wanted to say. In general, my job really is to make tools available. I literally get paid to make tools such that natural language processing is easier across the board, particularly for Rasa, of course, but I have plenty of byproducts there. But I cannot benchmark data for you. I need to hear from you. So please tell me what does and what doesn't work. And in particular, another reason why I think this area of more research is interesting is, in data science, we very often have this stuff that we optimize. That's where we do the grid search, where we try the BERT thing, and we really hit the power pedal to sort of flow all the tensors, etc. But there's also this area where maybe we shouldn't really optimize too much unless we really understand what our users care about. It's like a problem that happens in machine learning a lot, where we know that we're optimizing something, but we aren't necessarily sure if this overlap here is that big. So on my end, I would love to optimize more, but I would love it even more if people can tell me which tools are more useful than others, and I'll gladly contribute to projects that help you in that regard, especially if you're doing non-English NLP. That's it.
There are two questions as far as I can see in the chat, and I have a question as well. And the first question would be, have you considered, you showed only the two-dimensional representation because that's the only one that you can really highlight and
draw.
You can draw only two-dimensionally. But is there some type of tool that you've maybe thought about where you can just, first of all, switch through all of the dimensions that you have in your embedding space, such that you could just basically, in each projection, you just sort of highlight it, and if it's just a different projection and there is no cluster to the label that you actually wanted?
So there's two things there. So first thing is, I kind of showed it with this example. Let's make that big again. But in this example, like I have two charts here. One is bill length versus bill depth, and the other chart is flipper length versus body mass. So technically, two charts are 4 dimensions. So that's already an avenue that you can kind of do. A thing I would love to have in Human Learn, but it's like, good grief, a whole lot of front-end stuff I got to do. There is this project called HiPlot. It's from Facebook, and the idea behind it is you get these parallel coordinates, where you can sort of everything you see here is like its own dimension, and you can make a subselection on just one dimension at a time. And what I would love to be able to do is have like a word embedding where I say, well, let's reduce down to 10 dimensions and still keep most of the variance, and then say, oh, like, hey, there seems to be like I want to get the high value here, and I want to get the red, and okay, this might be a cluster. Give that a label. And notice that when I move this around, like the table at the bottom here also updates. So I think as far as UI goes, I think this is something I would love to have, but I really need to do the front end bit, and that is going to take like a lot of work, because this HiPlot thing is pretty cool. But right now they don't support you removing the HiPlot logo, and it's not really an open API either. So that's the main thing I'm battling with. But that's what I would love to take this labeling thing to next.
Okay, cool. So a question that was asked in the chat, but it was more of a technical nature. When you go down to the actual implementation of this last labeling
this thing?
GUI, yeah, exactly. I think one of the questions was, have you used PCA? Is there a clustering example? Because I mean, I guess the question is geared towards to get these nice clusters, you first have to implement some type of idea how this cluster will actually manifest itself, right?
Well, so the thing is, I would argue it doesn't depend on, there's a couple of axes there. So yes, you can use PCA here as well. It's just my experience, UMAP is just badass. It just always kind of works. I don't know what the secret sauce is. It just always kind of works. So I'm pretty happy with UMAP. I wouldn't really change that. Now, as far as this language thing goes here, I mean, you've got BERT you can use here as well. If you've got like sentences, you want to do the more contextual thing. I'm using the universal sentence encoder here, which works pretty well for English. It's pretty fast. But the thing with the language embeddings, in the end, they are trained on Wikipedia-like data sets. So if you're applying this on, let's say, Twitter data, I mean, Twitter is going to be significantly different. So then, you know, these super apparent clusters are just not going to be there, I think. But then if that's the case, I mean, this is more of a matter of, well, it depends on the data that you have. Like if you have Twitter data that's all about people complaining, you're basically going to see like one fat cluster in it. But if you have like a little bit of Twitter data that's super positive and some Twitter data that's super negative, yeah, then you're going to more obviously get clusters. But this is more of a data thing than a choice of embedding, in my experience at least.
Okay, and another question that was just posted by somebody from Austin, Texas. He asks if there's a GitHub repo. If you could mention it again.
Yeah, so there's not a GitHub repo for this presentation per se, but like everything that I'm showing here is super open source. So if you type what lies Raza, you'll get to this GitHub repository. It's fully documented. I'm pretty happy with the layout. If you're interested in the bulk labeling demo, if you type bulk labeling Raza, you'll actually find like 2 YouTube videos that explain the technique more in depth. And especially this video, like it just has all the links to the notebooks that you can just pretty much copy and paste. So like, again, everything I'm showing here is open source, and also all the embeddings that I showed earlier, they're also available in Raza. So if you're interested in making a Raza assistant and you're wondering, hey, do I have these embeddings? I'm trying to make them available. If there's tools missing, let me know on Twitter. I'd love to hear.
So there's actually a question regarding weekly supervised tools like Snorkel, if there's some type of compatibility, or if you have any experience or thoughts on how this might work in combination with it.
Yeah, so when I made Human Learn, I wasn't integrating with Snorkel, I was integrating with scikit-learn. And it's my understanding that Snorkel does the same thing. Like Snorkel won't integrate with my hobby projects. That's fine. Snorkel integrates with scikit-learn. It's so far so good. I will say, like, I think I have a slightly different approach though, because let's just go to the documentation page for Human Learn to show real quick. So inside of Human Learn, we've also got these function classifiers. So the idea is you can say, hey, here's a function that's like a weak classifier, and you can pass it any Python function. The keyword arguments become grid searchable. Like that's some of the stuff that we have here. What this library doesn't do though, which I think Snorkel does do, like Snorkel has this thing of, well, we have all of these weak supervisors, and then we combine them in a magic way, and then the prediction's better. I've never really understood what the magic thing is that they exactly do. So that's the one thing that my library doesn't. It's just some scikit-learn components, really. I believe that there are some clever things that Snorkel does there, but I'm really, really doing like the stupidly simple thing here. That's what I'm trying to go for.
Okay, I think there aren't any more questions in the chat, so that would be it from me. Does anyone else have any questions?
I have one person asking me for if we have Limburg's word embeddings. Oh. I think we do have them. I also think we have Fries, to be honest. I think there's a couple of dialects in here. Limburgen. I think that's the one. Yep. It should be said though, like there's definitely like a lot of things in here, but I think it's also still safe to say it's fairly European centric, this particular library, because everything that this library does is trained on Wikipedia. So if your language doesn't have like a reasonably big Wikipedia section, then there's no embeddings trained for you. So I don't want to suggest that this is like a, you know, homogeneously distributed language embedding package looking at the world. But there's definitely a lot in here, which is kind of nice. The only thing I do want to maybe mention is that Wikipedia data isn't perfect. I don't know if people heard what happened with Scottish Gaelic. The story here was, I believe it was like an American 16-year-old who basically thought, oh, you know, it'd be funny if I just upload like Wikipedia articles with words that sound Scottish. And no one really checked that. And apparently like a big chunk of the Scottish Wikipedia, I believe, was uploaded by a 16-year-old. And therefore all the word embeddings that were trained on that can't be super relied upon, which is probably happening with this embedding as well. But Irish Gaelic is also an interesting one. Someone just asked. Yeah, so Irish, I guess, is in here. What's also pretty cool, if you go to the documentation of this project, by the way, you can basically say the vocabulary size and how many dimensions, and then you can just get the bokeh visualization. So you can also just zoom in and get like an impression of all the words that are in here, all the subwords. So that's also something that you can do on your own time if you're interested in exploring this further.
So, Theo?
There's a couple of questions about how you export the data, but it's indeed just a pandas data frame. That's it. So you can save it in whatever format you like. If you scroll to the bottom here, you'll notice that I end up with this data frame, basically. I'm interested in maybe turning this into a package. It's just that I would prefer to have a little bit more feedback from the community before I do something more formal with it.
Great.
What's the best way to communicate with you? Via issues on some type of GitHub or?
On some type of GitHub. I also have a GitLab account, but I think it would be better if people post issues on the right repo. If you go to Twitter, if you find the guy in the ball pit, that's me. So if you type Vincent Pydata, you'll probably find me, but Fishnets88 is my alias. If you look for Raza or like Vincent Raza on LinkedIn, you'll also find me. If it's related to my projects, I certainly do prefer GitHub, but if you talk to me on LinkedIn, I will talk back. If you talk to me on Twitter, I will talk back. Any feedback is appreciated.
Thank you very much.
My pleasure.
Okay. Just see there was a last question. Can you add in the bokeh app via text input in new text and enter it in a label that already exists?
It's all happening inside of a Jupyter notebook, so no one is telling you not to do things. You will maybe need to code it up yourself though, if you want to add that feature. But if you can do it with Python code, you can do it inside of a Jupyter notebook, so it should be possible.
Okay. So yeah, thank you very much, Vincent. It was very interesting. Yeah.